Hello again. We continue chapter 11 with 11.2, series or infinite series. If you remember, we looked at infinite sequences, and this is the representation for an infinite sequence. Now, remember what this means, right? Basically, it's A1, A2, dot, 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 three dots, exactly three dots afterwards, sequence of numbers. Now, what happens if we add the terms of the sequence? If we add the terms of the sequence, of an infinite sequence, if we add the terms, we get what is called an infinite series. So the sum from a sub n, from n equals 1 through infinity, infinite series, and that will be a sub 1 plus a sub 2 plus dot, 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 exactly three dots, plus a sub n plus dot, 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 exactly three. Okay, here's an example how this will look like. So if we have the sum from n equals 1 through infinity, from 1 over 2 to power n, how will this look like? It will be like 1/2 plus 1/4 plus 1/8 plus 3 dots plus 1 over 2 to the nth power plus 3 dots again. Okay, so now the next question, or what we're interested in here is, does the infinite series have a sum? And if it does, is that a number, right? What is it? First of all, before we even get there, let's look at what it's called the partial sums. So partial sums. Okay, what does that mean? So the notation will be S sub 1, meaning the first term of the sequence. S sub 2 is the sum of a sub 1 plus a sub 2. In this case, it will be 1/2 plus 1/4. And so on and so forth. A1 plus A2 plus A3, dot, 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 S sub n, A1 plus A2 plus A sub 3 plus 3 dots plus A sub n. And of course, we can continue. So this is called the first partial sum. Of course, the second, the third, and this is nothing else but, and the notation is extremely important, for the nth partial sum. It's the sum from I equals 1 through n from ai. Okay, so this is finite because it ends at n. It does not go on forever, right? So this is the nth partial sum, and please note the notation. This is the notation for the infinite series, and this is the notation for the finite nth partial sum. Okay. Now, what we just created here, we created another sequence, basically. And we created what is called the sequence of partial sums. And this is my page 2. Good. Let's continue. So let's just make sure that the two concepts are clear. Sum of a finite sequence, that is S sub n, which I already wrote it here, but I want to recap. Sum equals 1 from I equals 1 through n from ai, and the sum of an infinite sequence that will be S, okay, with no subscript, and that is the sum from I equals 1 through n to infinity, sorry, from a sub n. Let me write it one more time. So S is the sum from n equals 1 through infinity from a sub n. So please make sure that this is clear. Now, the next step is, does the sequence of partial sums, does this have a sum? If it does, then we have S equals the sum from I equals 1 through infinity, a sub n, which is the same thing with the limit as n approaches infinity from S sub n. And another way of writing it, this is the limit as n approaches infinity from the sum from I equals 1 through n from a sub I. So what we are saying here is this, that the sum of the infinite series, is the limit of the sequence of partial sums. Is the limit of the sequence of partial sums. Okay? As we have it at the top. Okay, now a big if, and two different things have to happen here. Number one, if the sequence of partial sums converges, and also two, the limit, as we have it here, as n approaches infinity from S sub n is S, in other words, means a real number. If this limit exists, in other words, it's a real number, then if both conditions are fulfilled, then we conclude that the infinite series from n equals 1 to infinity from a sub n is convergent. And the limit as n approaches infinity from S sub n is S. And that equals the sum from I equals 1. I'm sorry, I meant to write from n equals 1 to infinity from a sub n. Okay, now if the sequence of partial sums is divergent, so is the infinite series is also divergent. One last thing before we look at different situations and play with some of the series is something called test of divergence. The test of divergence says that if the limit as n approaches infinity from a sub n, careful, this is the general term of the sequence, not the partial sums. If this does not exist or is not 0, then, so this is the generic term, right? Then the sum from the infinite series from n equals 1 through infinity is divergent. So if the limit does not exist or is not 0, then the infinite series is divergent. Okay, now if the I didn't mean to write the limit. So if, I will erase this, if the infinite series is convergent, automatically this implies that the limit from an as n approaches infinity is 0, not the opposite or the converse. No, this will not be true. If we look at the limit and the limit is 0, we cannot conclude that the infinite series is convergent. So careful here. Okay, so if we know that the infinite series is convergent, the limit of a sub n must be 0. One result that I would like us to remember is about something called harmonic series, which has this notation from n equals 1 to infinity, and this is divergent. So please remember, the infinite series 1 over n is divergent, and it bears the name of harmonic series. So let's see how we are on time. Very good. Good timing. So now let's look at problem 5. I would like to start with that because I created a video that is posted for you. So this is page 4. So problem 5 on page 747 is, please watch the video on TI-84. So in the problem has the infinite series n equals 1 through infinity from 1 over n to the third. We are asked to find the first 8 partial sums. So s sub 1, which is 1, and then s sub 2, which is 1 plus 1 over 2 cubed. And I created all these calculations, and I showed in the video how to determine them. Nothing by hand, please. 1.125, s sub 3, same thing. It's 1 plus 1 over 2 cubed plus 1 over 3 cubed. And I got sorry. So 1 point, okay. So this is 0.1620. And then s sub 4, and you know how we get that. So 1.777, they want 4 decimal digits. Okay, I got s sub 5. You will see them in the video. 1.1857. I got s sub 6, 1.1903. S sub 7, 1.1932. And then s sub 8, 1.1952. I also wanted to copy, because I showed in the video how to determine all sequence the terms of the sequence, the first 8. So let me also copy them here for you. So I got A1, of course, is 1. I got A2, 1. A2 was 0.125, yes. A3, 0.037037. A4, 0.15625. A5, 0.08. A sub 6, 0.00462962. A7, 0.002915545, and the last one, A sub 8, 0.00195312. I also showed in the video how to determine or make a decision on whether this series, the infinite series, is convergent, and we determined the 200 partial sum, the 800 partial sum, and so on and so forth. And they all appeared, those numbers appear to get closer and closer to, I didn't write that number to give it to you. Oh, I have it here somewhere. Okay, so it appears that it will get closer to and closer to 1.2020. So because of that, we will conclude that it appears that the series, the infinite series, converges. Okay. How are we on time? Okay, I'll stop here and continue in the next video. Thank you.